Can you all hear me all right? Nod, good, awesome. Right, my name's Chris. I've been writing Python things for about 20 years now. And before that happens again, bear with me a second. I'm going to give my laptop some coffee. During the course of that, like a lot of you, I've found myself writing lots of scripts. Some projects end up being tons of scripts triggered by cron jobs or however else you choose to run them. They normally start off looking like something like this, and then end up growing into other things, as we'll see. So this talks a bit about how those things pan out, where you don't want it to go, and hopefully some ideas that might help you take it somewhere nicer. Okay, so if we take this example, we've got a pretty simple script here. All it's doing is inserting some notes from a file into a database. As often happens with these things, someone else will come along and say, you know what, actually, I want to have a testing environment. I want to check things out before I do it, so they'll put some stuff in there to say, actually, here's this other database I want to put things into. Someone else will come along and say, well, actually, I now want to know what's going on. I can't see anything. I run your script. I don't get any output. What's happening? So they litter it with print statements, and it works for them, so everyone's happy. You get a nice little yay at the end when it works. Finally, someone sensible comes along and says, you know what? Actually, we need a real database here. SQLite's cute, but we're going to cut it. So we go for a real database, which is Postgres in this case, and actually someone says, look, that's got enough configuration with it with a username, password, database. We should probably just have a config file. So let's throw config parser in there and start storing our configuration there. But don't forget the little switch we've still got between prod and QA or testing or whatever you want to call it. And some liberal use of sys.argv, just pulling stuff out of the arguments because it was what it was doing before, so we'll just add some more of that. Someone else came along and went, look, all this argv stuff, I'm not good with guessing what these integers mean. Can someone do something sensible here? So we stick argparser in there. And we now have some help text. If we do, my script -- help, we get something nice out of it. And we no longer have these, we sort of have we have an args.path down there, and we have some other bits and pieces. We load our config from the args.config. Someone else comes along and says, yeah, but now there's all this print output, but I only want to see, if I'm debugging it, I want to see lots of it. If I'm just running it, I just want to see the one line at the end to tell me it worked okay. So I'd see this as a step forward in the sense that we're now actually using the logging library rather than printing everything. But it's added a whole bunch more stuff to it. So we've got this big chunk in the middle now, which is setting up the Python logging framework. The good bits, the bits down the bottom where we're actually using it, so you see that log.debug, and the log.info. So we can say, okay, if it's quiet, we'll just show nothing. If it's verbose, we'll show all the debugging stuff as well. But it's getting quite big now. And the problem is someone else is going to come along and say, well, I want to do something that's just sort of like that, but a bit different. I haven't really got time to think about refactoring because, there's a customer at the door and important things are happening. So I'll just copy it. So, and you know how this goes. If anyone's worked on projects like this before, someone else will go, I'll just copy that as well. And then everyone goes, well, I'll just have my own copy. And then it'll break. And there's a problem there in the sense that one's broken. How do you know that all those other ones aren't broken in the same way? Well, anyway, we better start testing it, so we're good people. So we finally actually wrap everything in a function that's not, so we can now import from this file without it just running the code. And we've got something we can, in theory, test. I say in theory because that's a monumental lump of stuff to test there. We've got a, tiny little bit at the bottom, and then the rest of it we just have to find a way to test. Okay, so we can see what we can do about that. Who here has used PyTest? Lots of people? Good. We sort of throw up some fixtures at the top there. So we've got a database connection that we can use for our testing. Temp directory is something from another package that I wrote called test fixtures, which just gives you a nice little temp directory that has features that mean you can write tests more easily. So you can see you could do a dir.write there, a couple of dir.writes. So we've got those two fixtures, and now we've got a test for our thing script, to be polite. In order to be able to actually test it, though, we have to write a config file to disk, Because we're in a testing environment, we probably need to get the database name and user and password from the environment to make sure we've got something that's not production or whatever. We need to mock out sys.argv. We need to capture all the stuff that's being printed as stood out, so we can make some sensible assertions about it. And then finally, we can actually call our script. You know, we've got this much setup here, and then we can finally do that one little line, which is actually, does this code work in any way, shape, or form? And then after that, we can actually make some testing assertions. So we check that our row made it into the table, and we check that we got the output that says, yeah, we successfully inserted it. I wouldn't like to guess what the code coverage is in there in terms of how many lines our tests are executing. It's probably, actually in this one, it's probably catching most of them, but you know, with scripts that have a lot of conditionals and bits and pieces in there, you probably find that you need a lot of big tests like this. And of course, the way the code's currently structured, every single test has to have this monumental setup, all this overhead, and then eventually you get to check one little thing. I suppose you could factor that out in the test, but it's probably better to solve the problem in some other way. So where could we go from here? There's a couple of anti-patterns for me that I'd just like to mention in passing. The first one, which is, well, you know, classes are good, so why don't we abstract everything into a class? So on the left here, we've got our original script. On the right, we've got a sort of refactored into a base class that, you know, provides scripty things that we can use. So our logging stuff's gone into a method called, you know, our arg parsing stuff's gone into a method called load args. We've got a slot that we can insert our own scripts arguments in there. We can load configuration up. We've got setup logging. We've got a horrible property thing that becomes a database connection when you touch it. And then, of course, we have to have a magic method that we actually run that calls all the things we set up and all the hooks we've set up. And then finally, we can stick our script in there. So that's great. So now when we have a script, it looks like something here on the right. So it's much shorter. We don't have any common, you know, we don't have any of the stuff that was shared between all our scripts. We just have the, you know, our argument that we need for this script, which is the path of the file we want to insert, and then the code which loads that file and, you know, does the logging and all this good stuff. So what's so bad about that? So where I've bumped into this before, the problem is you'll get a sub-selection of all your scripts will need some extra thing. So the obvious thing for a lot of people then is to just shove it on that base class. So your base class ends up collecting stuff in load args. So when you do -- help, it's about 3 pages long, one of which you might have used once upon a long time ago. The other problem is that with these insertion points, people will inevitably find that they need something just before or just after the ones that you have already. So they'll add another one. So that run method down the bottom will just get longer and longer and calling a lot of empty methods. Or I suppose the other option would be like, you know, some horrible hazard or things and they're saying, well, does this method exist? If it does, I'll call it. So that's one kind of, you know, this is the factoring out a base class approach that I've seen not work very well. The other one, which is a smaller problem, but I thought I'd mention, is the splitting configuration here. So this, we've taken our script now and we've said, okay, what we actually need to do is be able to specify the DB name, user, and password as environment variables. So if you're running it in a Docker container or some kind of other containerized environment. But we also might want to be able to override the config file, you know, via the command line. So we've grown some command line arguments there. That's actually all fine. That all makes sense. The anti-pattern here is the kind of script code's way of getting hold of that. You know, in this example here, we've mixed in getting hold of the configuration from where that configuration is used, so that everything that uses these options now, in this case it's database, so it might not be that frequent, but other stuff, you know, everything that needs to know about that now needs to know to look in the args first, then in the environment, then in the config. And if you get those orders wrong, then you'll get some random script out of the 100 in your environment that behaves magically differently. And it's like, oh, on this one, the environment wins, and my command line argument that saved me from wrecking prod did not help. Oh dear. So anyway, how do we get here? When you end up with projects that have lots of these kind of command line run scripts, you always end up needing framework code. So generally stuff that logs things, manages database connections, picks up user config, overrides, the stuff that we've mentioned so far. However, the projects I've bounced through over the years, generally each one of those scripts only has one core thing that it kind of does. And the rest of it is kind of like shared config that, you know, ends up being used by a lot of the framework and then maybe a little bit by your script. The script itself often doesn't actually need to know anything about the config. So how do we end up in such a mess? How do we end up with these, you know, these monster things here? Okay, well, let's wind all the way back to our little simple script. And what could we do differently to not end up where we ended up? Okay, so if we take that little chunk of Python and turn it into a function. So this function now just does the one thing that our script does. And it doesn't do any magic about instantiating the resources it needs. It just says, I need a path to tell me where the file is, and I need a database connection. I don't know where they're coming from. It's not really my responsibility. Now we're here. We also have, from my perspective, the correct use of the Python logging framework. I'll go into that a bit more here in the sense that what we're doing here is saying, I need to log these messages. I need to record this information. As the person writing this code, I don't have any opinions, and nor should I, about where that stuff goes. Is it going to go to file on disk? Is it going to go std out? Is it going to get piped off to syslog to go somewhere else? It's not important for this code. So this code's just saying, I need to generate these messages, but something else is going to take care of where those go. The lovely thing is it means we can now actually sensibly test this. So again, we've got some PyTest fixtures there. I'll throw in another test fixtures one there, which is log capture. Who here tests their logging? Ah, that's better than I was expecting, but cool. A lot of people don't because it's perceived as being hard. That little fixture there just makes it trivial. We've still got a temp directory, we've still got a database connection. Not a lot's changed there. Although you'll notice that actually that database fixture now returns or now yields the connection, not the cursor. It also doesn't do any commit. You'll notice it's creating the table, but it no longer does a commit beforehand. And that's because, as an aside, script code that deals with databases, or any application code that deals with databases, unless you really need to, shouldn't manage transactions. It should be working within a transaction that's managed by someone who has a high-level try-except to catch its mistakes. So now our test actually becomes quite a lot simpler. We've asked for our fixtures from PyTest. We say, give us a connection, give us a log capture. We've written a file that we want to load up, and then we've called our function with the two things it needs. And then now we just have the checks. So rather than that whole kind of like having to write a config file on disk, looking at std out, worrying about the logging, we know that we've generated the correct log messages here. And that's generally the thing that's done most frequently. You'll have a lot of code that generates log messages, and that you should probably test. How that logging is configured to go to wherever you need it, that's probably a one-off thing that will hopefully get written once in your entire collection of scripts and never done again. And so here we're testing the important bit and not worrying about the other bit. So what about the rest of that script? Where does that go? Well, in the same way that we've abstracted out a particular component here to do this, we can do the same with the rest of those. For our argument passing, we can say, okay, let's have a common arguments function that needs an argument parser and parse args that returns the parsed args. You'll notice who here is using Python 3 only now. That's actually gone up a lot. Makes me very happy. Anyway, so sexy new annotations here. So we say parser is going to be an argument parser, and we say that parser to parse args also needs an argument parser, and it return the namespace from that. We'll see why we've bothered putting those on other than to make all our editors and Guido happy in a bit. On the config side, we can now say, here's a little function. All it does is load the config. So it takes the path our configuration is at, uses YAML.safeload. I learned this morning, so I'm not doing load anymore. You can no longer delete all my everything by sending me a bad config file. And then coming back to my second anti-pattern here, we have one function which takes the command line arguments and the config and does the environment variable, and it puts all of those together. Okay, I missed off a line there. Sorry, there's one more line on that example, which is basically it puts all those together and stores them in that single config. Yeah, so the load config will give you back a nested simple Python data structure. Adjust config will basically mush together the other bits, but you end up with that one config object that has all your configuration in it. On the logging side, so we now have a function that does our setup logging. It doesn't know about where the things telling it to configure come from, so it doesn't reach into our argument parser. It doesn't know anything about that. All it does is it knows it's got a path it might need to log to. It might be told to be quiet. It might be told to be verbose. Another bit which we didn't really have before, so this is a context manager, which inside that context, when you enter it, it'll log that you've come into it, and on the way out, it'll log if anything went wrong. We could add some more to this, say, if it completed successfully, you could log it info saying completed. We could add some other stuff in there, say like how long this took to run, or what machine it ran on, whatever else we needed. But that's important because we probably want that for all our scripts. But each script having to think about that, someone's going to forget an important bit or copy an older version of the code. They're not going to end up with the information that you need when something goes wrong. With our database, we now have a context manager. In this case, the function just takes the username, the database name, username, and password, creates the connection, hands it off to whatever needs it. Once it's done, it commits the transaction. If anything goes wrong, it rolls back and logs a message, logs the traceback saying, hey, this went bad. So now we've separated out all the different components of our framework, and we can actually unit test those all individually and make sure they all work in all the edge cases, and we don't have to worry about setting up all the framework around each one of those to get stuff done. But how do we wire all of those together? We could do it manually. So here's our script on the right now. There's our function, there's our add args, the one arg that's needed for that script. We've got a logger that we get hold of just to log stuff to from there. And inside that main block, we now call the sort of script helper. So we give it the function, we give it the args it needs to add. And then it manually goes and instantiates an argument parser, adds our common arguments to it, adds our args to it, loads the config, sets up the logging, logs anything that goes bad, deals with the database transaction, and finally calls our function. The eagle-eyed amongst you will maybe think about what goes in that ellipsis, what goes in that triple dot. How do we know what to call our function with that we pass in? And it's going down this path that led me to end up writing a thing called mush. Mush is a dependency injection framework. So if you've used PyTest, you've already used dependency injection. When you ask for fixtures in PyTest, that's dependency injection. So you're saying, I'm not going to try and create the things I need. I'm just going to sort of say what I need, and someone else I will trust to bring those to me when I need them. In the case of mush, that means all the individual components specify what resources they need and specify what resources they return. So that's where those type annotations that we saw in the previous examples were coming into play. Mush also provides these things called runners, which is basically a way of stapling components together, and it then manages the resources that are around and maps them through to what you need. So that all sounds big and complicated and scary. It's not really. That's a runner, a little bigger. So we've got our two functions there. We add them to the runner. When you call the runner, it just calls the two functions. There's no magic. Where things start getting interesting, on a runner you can add a label. Yeah, so here we've made a runner and we've put this label called middle in, and then at a later date we can add another function into it. So now we've changed the order of calling these functions and added something in, but still the runner is just the same to use. So we call it function 1, function 3, function 2. Let's put that back the size it was. So how do we tell the runner what resources are around? So we've already seen one example of this, which is with the type annotations of Python 3 compatible. In this case, we can see our magician takes a fruit and returns a citrus. Something that's not standard Python 3 type annotations there, that citrus is a string. Rather than having to specify types all the time, which can get quite tedious, mush will just let you use names, so you just return a string. So in this case, we've got, we can see we add those things to our runner, we call the runner, and everything gets mapped through as you'd expect. So the apple tree produces an apple, our magician turns it into something citrusy, and then we juice it to make some juice. Other ways of doing this, if you're on Python 2, you don't have type annotations. So mush provides a couple of decorators, so you can say this requires and returns explicitly. That's also helpful if you're using something Python 3-ish and it uses the type annotations in a way that isn't compatible with what you want to do with mush. So that's exactly the same as was before. Here's a slightly different take on it. So this is saying, look, actually, I just don't want to have decorators and type annotations all over the place. I just want to use the names of the arguments. And that's default configuration, which is if you don't specify anything else, when mush comes to run a function that you've added to a runner, it will look for resources named with the names of the arguments. So here it's going to look for something called apple and look for something called citrus. The declarations on the ones above have told us that we're returning those. So the first one says returns an apple, the second one returns citrus. Sure enough, when we call at the bottom, it all maps through. The last one, and this is helpful if you're using callables that you have no control over or no right to go and molest, is that you have a runner explicitly saying what it needs, what happens with the callables at it at the time you add them to the runner. So here we're saying requires and citrus. Same again. So back to our tested function. You can see we've now marked this up. We're saying this needs an argument parser. We need a PsychoPG2 connection, and I've used another little mush trick here to say, actually, for path, I want the path argument. So from the namespace returned by argpath, please can you give me the path attribute? And then, our code is still testable in exactly the same way it was before. How do we assemble all that? Okay, well, it's basically just assembling the runner. So you can see we add the bits and pieces. We've added a couple of labels in there. And then to use that, now over on the left, we have that little block at the bottom where we say, okay, we've got our args, and we've got our function, and then we call it. So the only line that we now can't unit test easily is the one which is just main and 2 brackets. Another take on this would be to use a runner factory. So this now we have a function that does pretty much what we had before. I've taken the labels out here because it just made it a little bit shorter. Why would you want to do that? Well, in that case, actually, the stuff in your script becomes very short. It's just a one-liner there. If you have a lot of scripts, that might be important to you. So we still have to test that base runner. This is still going to be a big pain. You've only got to do it once, though. Remember, you've tested all the components heavily individually, so all you have to test is that you've linked them together correctly, so get kind of one path through there. Testing the scripts, however, you're going to need to do a lot of these, and we're mainly talking about making sure that while we've tested insert note on its own, the stuff we've got down the bottom is still, if we get that wrong, if we add in the wrong slot, or if we use the wrong callable in the wrong place, that might just be correct. How do we test those? So we still have our code over there on top left. We still have our fixtures bottom left, and then top right we now have our new test code. So the test looks much the same, except we've got this run with line now, which is pretty much close to what you would type on the command line. And then how that works is we take the runner that we had, and using some other mush things, we now create a new test runner, and we take out the bits that we would have added into the framework stuff and put them in our new test runner there. So we staple in some false argv, and we take the args and body that we've added and run those. So the summary of this is, as early as possible in a project where you have lots of scripts, keep your tasks and framework separate. Abstract those out when you can. Make sure you test them individually. Don't try and test big lumps, except for the few places where you're integrating and need to. Have one source of framework configuration. So if you do have to take things from environment variables and command line arguments and config files, try and get those all into one simple Python nested data structure that you can use as configuration early on. If you are using mush, and I'm only mentioned that particularly in this talk because I wrote it and I want to do, but the bits and pieces in there, use lots of labels and write a run with helper like we've seen. Okay, so the tools I've used, these are links to them. So the mush is there. Test fixtures is another library that I've looked after for a few years now, and that provides a bunch of things that make it nicer to write unit tests. The ones we've seen in here are log capture and temp directory. Probably the other one I'd really recommend having a look at is compare, which is a replacement for using your assertion stuff. The interesting thing it's done that I haven't seen done elsewhere is if you have big, nasty, nested data structures, it will actually give you useful feedback when those aren't equal, rather than just going, hey, here, this big blob, that's not equal to this big blob. It'll say, right, well, it wasn't equal in these keys, these list items, and these values going down. But that's time for another talk. In terms of options as to what you can use, we've mentioned argparse. Argparse is actually pretty gnarly underneath the hood if you've ever looked at the code. Click is a whole other take on command line arguments. I would definitely recommend you have a look at it if you're doing lots of command line argument-y type stuff. For config files, please don't use config parser. Any files should be assigned to the bin of history some time ago. PyYAML is there. It's great. Lets you load files up. I was hoping several months ago to have configurator further on and maybe include it in this talk, but this is basically a helper to take simple Python data configuration and layer it together. So loading up multiple user files, dealing with layering on command line arguments, merging configs, that kind of stuff. Hopefully it'll get there at some point. For validation, so you've got your configuration of simple Python data structure. You want to make sure it's actually correct and it's going to work for your application. Voluptuous is a great way of doing that. Mushroom's more of a serialization thing, but again, you can use it for validation as well. I'll sort of throw it in there. Have we got time for one question, do you think? Not really. We're kind of out. Yeah, all right. If you have got any questions, come find me. I'll be knocking around for the rest of the week. Or alternatively, drop me an email, either of those, or hit me up on Twitter. Thank you very much.